Hello, advanced algebra students, and welcome back to another video lesson as we continue to explore exponents, rational exponents, simplifying and solving. Today we do focus on the solving part. Before we get to that, though, I just want to give you some feedback on the target practice from yesterday. Here are those answers. A couple of key things to remember. When we simplify, so in like numbers 1, 2, and 3, when we simplify, we are only looking for the positive value, only the positive answer. Whereas when we solve, if it is an even root, the fourth root over here, the fourth root on number 6, we are looking for both positive and negative values when we solve. If it's an odd root, we're only going to have one answer. So those are the big things. The second biggest thing is in the number 5 here, when I have a v to the 1/3 power, right? After we divided both sides by -3, we get v to the 1/3. To undo that, we multiply or raise it to the power of its reciprocal. It's reciprocal. Okay, so both sides to 3. Whereas over here, if it's to the 4th power, we really raised it to the 1/4, which is its reciprocal, meaning we were looking for the 4th root of 16, plus or minus 2. Okay, and so today we're really kind of focusing, though, on the solving part now. How do we actually isolate the x variable, and then undoing this rational exponent? And so if we recall from what we did earlier in lesson 7-6, we have to solve this one step at a time by truly isolating the x. And so our first step would really be to subtract 7 from both sides. All right, I've got to move that 7 over, leaving me with 1/2 x to the 1/4 equals 5. And then we can multiply by 2. That'll get rid of the 1/2 out front. Okay, if I multiply them by 2, I've got x to the 1/4 equals 10. And I should just write that a little bit different. X to the 1/4 equals 10. How did we undo 1/4? Well, we raised it to the power of 4. Same thing on the right-hand side. X equals 10,000. And so we're really trying to undo these things, these rational exponents, by using those reciprocal powers, because the power to a power property, right? X to the 1/4 to the 4th. If we had x squared all raised to the 5th power, the rule said we could change this to x to the 10th. Because we multiplied those, a power to a power. Same thing here, 1/4 to the 4th. If I multiply those, I get x to the 1st, which is what we have down here, x by itself. If I do anything to one side, I have to do it to the other. All right, now we're going to use that along with the knowledge that we had from yesterday on simplifying some of these rational exponents, remembering what the numerator does, remembering what the denominator does. So the first one, y to the 4/3 equals 625. All right, so if we're trying to get y by itself, we have to raise it to the power of 3/4, the reciprocal. And if I do that to one side, I have to make sure I do it to the other. That's that golden rule in math. Whatever we do to one side, we have to do to the other. This gives me y equals, and now if we rewrite the right-hand side, we're looking for the 4th root of 625. And then we're going to raise that to the 3rd power. Raising it to the 3rd. Now, we got to be a little bit careful here, though, because the 4th root of 625 could be a positive or a negative value, right? It could be positive or it could be negative. That's actually going to be 5. And then we have to take each one of those and raise it to the 3rd power. 5 to the 3rd, 5 times 5 times 5 is a positive 125. Or if I do -5 to the 3rd, I get negative 125. So we could write it as plus or minus 125. Now, today we're just going to focus on finding the positive one, just finding the positive answers. And tomorrow we'll work a little bit more on what happens if I do have some of these negatives. So for today, I'm only going to focus on finding the positive. Letter B, again, we're trying to isolate the x value, so we need to divide by 2, or x to the 4/5 equals 81. To undo that 4/5, that power, I got to raise it to the power of its reciprocal. And if I do that to one side, we got to make sure we do it to the other. So that means x equals the 4th root of 81 raised to the power of 5. 4th root of 81 should be 3. And 3 to the power of 5. 3 times 3 times 3 is 27. Times 3 is 81. Times 3 is 243. 243. And so, again, using the reciprocal and then remembering what did this mean for us to do? 81 to the 5/4. All right, so here we go. Another one, your turn. Why don't you pause the video here and take a moment to try and solve these two. See what you get for answers. Okay, first step. We've already got x isolated, so we can raise this side to the power of 5/2, which means we've got to do that on the right-hand side. Or x equals the 2nd root, which is also the square root, of 4 raised to the 5th power. The 2nd root of 4 is 2, and 2 to the 5th power is 32. 2 times 2 times 2 times 2 times 2. Right? And again, the test that you're going to have coming up later on this week is going to expect a lot of work, very similar to what you're seeing here. Again, if you only have an answer like this at the end, that's only one out of the potential, probably 3 points that are listed here. All right, you got to show your work. Letter D, we got to subtract 6 first, and we get x to the 3/2 equals, that's 64. We're going to raise this to the power of 2/3. We're going to do the same on the other side, raise it to the power of 2/3, meaning x equals, we're looking for the cubic root of 64, that answer raised to the 2nd power. Cubic root of 64 is 4, and 4 to the 2nd power is equal to 16. So we get 16 on that letter D. So I'm hoping that you see the patterns here, how we're trying to isolate the variable. I hope you can see how we are using the previous lesson to transition or convert 64 to the 2/3 into the cubic root of 64 raised to the 2nd power. Now, what happens if we have negative exponents? Right, those negative exponents. Well, not a lot changes, to be honest. We're still going to raise it to the power of just the reciprocal, right? -3/4. Because I need these two numbers, this power and that power, to multiply to a positive 1. I'm going to do the same thing over here. Raise it to the -3/4 power. Or y equals the 4th root of 625 raised to the power of -3. Right? We're going to use the negative with our numerator. The 4th root of 625 is 5, and then we're going to take 5 to the -3rd. But the rule for negative exponents is to move it to the bottom. And again, to show what is 1 over 5 to the 3rd, or 1 over 125. So again, here's our final answer. On a test, if you only have this and you've missed quite a few steps along the way, you're not going to get full points. Okay, raising it to the power of its reciprocal and then going through the process that we learned yesterday. the fourth root, because 4 is our denominator, then raising it to the power of -3. Why don't you try letter B? Pause the video here and see what you get. All right, we're raising it to the -5/3. All right, raising this side to the -5/3. So I'm looking for the cubic root, oops, forgot to write my cube, 3, the cubic root of 1/8. And whatever I get for that answer, I'm going to raise it to the power of -5. The cubic root of 1/8. That's like looking for the cubic root of 1 over the cubic root of 8. Cubic root of 1 is 1, and the cubic root of 8 is 2. So that inside parenthesis, cubic root of 1/8 is 1/2, and I'm raising 1/2 to the power of -5. Now the rule for powers was this power gets applied to both, 1 to the -5th power over 2 to the -5th power. And the rule again for negative exponents was if it's on the bottom, move it to the top. If it's on the top, move it to the bottom. 2 to the 5th is 32. 1 to the 5th is 1, or we get an answer of 32. A lot of steps in that one to go through that entire process, but it uses a lot of the rules we've already done. Now, the last one is a story problem, and I want to talk about this one specifically as we talk about a no calculator test, even though it says round. Suppose Gary has $75,000 of the $200,000 he hopes to have in a retirement account in 8.5 years. What interest rate compounded annually does Gary need to meet his goal? So he's already got $75,000. His goal is to get to $200,000 in 8.5 more years. What are we looking for over here in the formula? Well, we are looking for the rate. We don't know the rate. What is that rate? So the amount that he wants at the end is $200,000. That equals the principal, what he started with, $75,000, times 1 plus the R value. We don't know that. We're looking for the rate over N. If it's compounded annually, that means 1 time a year, all to the power of 1 times 8.5. 8.5 years. Right? So if we're looking for the rate, that means we've got to move the 75,000 to the other side. Well, 75,000 times that value means the opposite, or to undo it, is to divide by 75,000. Now, some of you will know to cross out zeros, and you certainly can cross out the same amount of zeros on top and bottom if you want. For this case, you don't have to. In the non-calculator part, we can leave it as a formula. Equals 1 plus the rate. I'm just going to put rate because divided by 1 is 1. 1 times 8.5 is 8.5. If I'm trying to isolate the R, what do I have to do to get rid of the 8.5? Well, we've got to raise this entire side to the reciprocal, to the 1 over 8.5. I got to do that over here as well. So 200,000 divided by 75,000, all to that power of 1 over 8.5 equals, what are we left with over here? 1 plus R. And how do we get that R by itself? We'd have to subtract 1. Or R equals that whole thing over there. And if it's a non-calculator test like you're going to have, you can stop right there, right? We can't technically, there's no way, I don't think any one of us can do that mentally. We want to stop right there on that no calculator portion to show that the rate would equal this. meaning we could go to Desmos and calculate it to the nearest hundredth if we needed to. All right, so again, a lot of review of previous rules of our exponents and rational exponents. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.